there, welcome back to the channel. Today we are going to learn about materialized views, and by the end of this video you should be able to generate dummy data in Postgres, create normal views, create materialized views. You should be able to refresh materialized views. You should be able to state the differences between normal views and materialized views. And you should also be able to state the advantages of using materialized views, and we shall end by stating the disadvantages of materialized views. So let's get started. Let's start by generating dummy data that we shall be using for the rest of this video. For this, I am going to create a users table having 3 columns. ID as the primary key, name for the name of the user, and created at as the time when the user was created. So create table users, I want the ID to be serial, primary key, then I want the name to be text, and I don't want it to be empty. Then I want created at as a timestamp, time zone. So let's run this. Voila, the table is created. We can refresh here and we'll see the users table created. Now let's insert dummy data into the users table. I am going to use generate series function to generate the dummy data that we are going to insert into the users table. So let me write a comment here, and this is going to be insert dummy data. So here we're going to say insert into users, and the columns that I want to populate will be name and created at. And the data that I want to insert is going to be from the select statement. So select, I want to select a name. I'm going to use my name. So Dalmas from DaliCodes. And I'm going to concatenate it with the variable. So I'll call it I. This variable we are going to get from the generate series function. Then the second column is going to be time in seconds. You're going to see why I'm calling this variable time in seconds when we are creating generate series, when we are generating series. So for the first variable, we're going to say from generate series, and I want to generate series from 1 to 20. So we shall have values starting from 1 to 20. Those will be 20 values. And I'm going to do a full outer join with another generate series. And this generate series is going to generate dates. I mean timestamp, not dates. So this is going to be timestamp of a time zone. And the first date will be 2013, January 1st. Then I want to generate till timestamp 2023 December 31st. So the interval between the times, I want it to be seconds. That's why I'm saying time seconds here. So interval should be 1 second. Then I'm going to make this readable. So this will be as time seconds. So this is the second variable here. This is the first variable. I'm going to put a space here. So this will be a full auto join. That means that the name will be repeated several times. But this is just a dummy data for us to play with. So I'm going to run this. I have an error. So what's the error saying? Column I does not exist here. So I'm going to say this is as I. So this is rather taking too long. I'm going to cancel this, and I tried this for 3 years. So I'm going to stop this. Then I'm going to say from 2013 to 2016. Then I'm going to run this. Well, this is also taking too long. So far it has been running for 9 minutes. I'm going to stop this, and I'm going to work with 1 year, because I think this is going to be like 2 billion rows. So let me cancel this and change this from 20 to 2013 December, just 1 year. And let's run this. So this took less time. No, so this took a lot of time, and I had to endure the time. Now let's check the quantity of data that we have in the users. So select count all from users. So this took close to 3 minutes to execute, and we can see from the users table we have around 628 million rows. Now let's have a sneak peek into the table and see the kind of data that we have in the table. So select all from users. Let's look at the first 10. So here we have the ID, the name. So you're seeing the name repeats because of the full outer join that we have between these two series, and then the time in seconds. Now let's write a simple query that returns number of users grouped by date the users were created. So this is going to be a simple query. And this query is going to select, what I want to do is to select count of IDs, and this is, I'm going to call this number of users. Then I want date of created at, and this will be created it. Then we're going to select this from users, and we're going to group by the second column and order by also the second column in ascending order. So let's run this and we'll see how long this query is going to take. So this query completed in 2 minutes and 19 seconds, and we can see where this is taking us. The table is too huge, more than 500 million rows, and doing simple manipulation of data on this table takes a lot of time. So what we're going to do next is to create views and see how we can improve the performance of queries on this table using materialized views. So the first thing we're going to do is to work with the normal view. I'm going to create a normal view from the same query. Please take note of the time it took to execute this query. So to create a normal view, we're going to put a comment here, create normal view, and the syntax of the normal view is going to be create view. I'm going to call this view daily signups then I'll just copy this query here. So I want to, every time I'm querying this view, it should return to me this data. So this is how the creation of the view looks like. This is not going to take so long. It has taken less than a millisecond, like 100 milliseconds to execute this. Now let's read from this view that we have created. Remember, this is not a materialized view, this is just a normal view. So I'm going to select all from daily signups. Remember, previously this took around 2 to 3 minutes. Let's run this and we'll see how long this will take. So querying this view took 2 minutes and 18 seconds, close to the same time it took to execute this. And essentially, when you query the view, what is executed in the back end looks like this. So it looks like if you would have written select all from a subquery of the underlying query of the view. So executing this is the same as executing this. So I'll just say this one looks like below, or the spelling of below. Yeah, so when we try to select all from a view, it's like selecting all from selecting the subquery. That's why it takes close to the same time as executing the underlying query of the view. So in simple terms, a view looks like a storage of our query, and when the view is called, our query is executed. So what is a view? In SQL, or if you want to call it SQL, A view is a virtual table based on the result set of an SQL statement. A view contains rows and columns, just like a real table. The fields in a view are fields from one or more real tables in the database. You can add SQL statements and functions to a view and present the data as if the data were coming from one single table. Now, after knowing what a view is, let's now move on to materialized views. And we shall begin by creating a materialized view using the same query that we have been using. So I'm going to comment here. So the syntax for creating a materialized view is the same as the syntax of creating a normal view. So I'm just going to copy this. The only difference is just one word for now. So create materialized view. And it will be the same. We don't need this. So I'm going to run this. It's going to take long to create the view. Remember, to create the normal view took less than a second. It was close to around 100 milliseconds. To create a materialized view, the whole of this query needs to be executed, and the data will be saved somewhere. So that's why it takes long. I'm going to run this. But daily signups already exist, so I'm going to rename this as materialized daily signups. So let's run this. And it should take around 2 to 3 minutes, the same time it takes to execute this query and returning a result. It may take more than that time because it will need to save that data somewhere on the disk as a table, as a physical table. Now, this took the same time as the time it takes to execute this query. Now, we can look at how long it will take to query the materialized view. So select all from this. So when I run this, it takes less than a second to get data from this view. Remember, getting data from the normal view here took us 2 minutes and around 17 to 18 seconds. And fetching data from a materialized view takes less than a minute. So that means that the speed for executing this query has drastically reduced by thousands and thousands of times. So what is a materialized view? Materialized view is a duplicated data table created by combining data from multiple existing tables for faster data retrieval. The difference between a view and a materialized view is that for a materialized view, the data is stored as a physical object on disk, while for a view, the normal view, the data is virtual and not a physical object. This means when retrieving data from a materialized view, the data is fetched from a table that is already created as a result of the query that is underlying within materialized view. For our case, this is the query that generates this table here, and this table is the physical table that is stored on the disk. This means that when retrieving data from materialized view, the data is fetched from the table created as a result of creating the materialized view. While fetching data from a view, the data is queried from original tables using the procedure stored by the view. So for materialized view, the result of this query is stored on disk as a physical table or as an object. While for the normal views, the result of this query is not stored. The query itself is stored as, I can call it a stored procedure or just a query stored somewhere. And when you try to query the normal view, your query is the one that is executed. But for materialized view, this query will not be executed. What will be executed is just fetching data from the table that is stored. So that is the difference between normal views and materialized view. The main advantage of using materialized views is the quick execution of queries to fetch data from those views. While the main disadvantage is materialized views are stored on disk and physical data takes up storage space. This means that when using materialized views, you need to take into account the storage space that will be occupied by the materialized views. Now, is data in the materialized views always up to date? Let's add more data into the users table. So let's copy, where were we? Adding data, view. Let's add data into the users table. Yeah, we're here, inserting this. So inserting dummy data. What I want to add now is a month of data. So let's add December of 2012. So 31st of December of 2012. Let me run this. This will insert more data into the users table. This query executed in 2 minutes, and we now have data of 2012 into the users table. Now let's run select all from materialized views and see if we have data for 2012. So this has executed, but we can see that we don't have 2012 data. And we can also be sure that we don't have it because the underlying query of materialized view is ordered in ascending order. So we expected it to be among the first records. So materialized view need to be refreshed for them to fetch new data from the underlying tables, and that's why we don't have the new data into this materialized view that we have created. Now let's refresh the materialized view. Refresh materialized view, and the name of materialized view is this. The refresh takes long because data is being queried from the underlying table, and modified or transformed based on the underlying query, and then data is saved into the new table. In our case, the new table is materialized daily signups. So this is going to take some time. So refreshing the materialized view took 2 minutes and 20 seconds, close to the time it takes to run the underlying query. And this still, I can repeat this, this is because we are executing the underlying query and then moving the data into the physical table. Now let's look at the materialized view and confirm that 2012 data is there. Voila, we can see that now the 2012 data is indeed in the materialized view. It is important to note that refreshing a materialized view in any system, it could be Amazon Redshift, it could be Postgres like the one that I'm using now, can be resource intensive operation. Like now, the way you've seen, it takes time, and also it uses CPU, it uses compute. And especially if the underlying data is large and the query defining the materialized view is complex, it's going to take a lot of your compute and a lot of time. So therefore, it's advisable to plan the refreshes during off-peak hours, or consider using automated scheduling mechanisms to manage this kind of refresh process. And for our case, this kind of refresh is full refresh. And full refresh is not the only way you can do refresh for materialized view. We can also do an incremental refresh on the materialized view, but we shall not see how to do this now, but we are going to see how to do incremental refresh on materialized views on a separate video in the coming weeks. So you can subscribe not to miss it. One question though, are we able to drop tables, the underlying tables of a materialized view? So let's check if this is possible. I'm going to leave a comment here, and I drop underlying table. So let's drop users. And run this. We are facing this error. View daily signups depends on the table users. Materialized view, materialized daily signup depends on the table users. Cannot drop table users because other objects depend on it. So that means that the same way we can't drop underlying tables for views, we also cannot drop underlying tables for materialized view. So if you're working for an organization where you have ETL processes that do override tables, where your tables are dropped and then new tables are written, those ETL processes will be failing because you cannot drop tables having materialized view. So you need to think of other ways of writing your ETL processes if you would like to use materialized view for tables that are dropped every now and then. So The only way we can drop the underlying table is by dropping cascade. So drop table users, then you do cascade. But this will also drop all other objects that depend on the users table. That means that when I run this, the daily signups view will be dropped and materialized daily signups will also be dropped. Well, that is what I have for you today. Check the code and references in the description below this video. Let me leave you with a quiz on the end screen of this video, and until next time, take care.